Remember that awesome scene in the superhero movies? A character, maybe someone like Sue Storm, the Invisible Woman from the Fantastic Four, just vanishes. Poof! She's standing there 1 second, and the next, she's completely gone. You can see right through her to the wall behind. Movie magic. Sneak past guards, surprise enemies in a fight. It gets you thinking, could that ever happen in real life? Could a person, a car, even a whole building just disappear from sight? Comic book fantasy, or science? Let's consider it scientifically. Centuries of fascination, not just a power, a scientific puzzle. H.G. Wells' The Invisible Man. Scientist turns invisible, things go wrong. These stories raise possibilities and dangers. What if we could control the thing that lets us see? Let's break it down. Seeing is a team effort between light, objects, and your amazing eyes and brain. Think about an apple sitting on a table. A light source, like the sun or a light bulb, sends out countless tiny packets of energy called photons. These photons travel in straight lines, racing through the air until they hit something. When they hit the apple, a few things can happen. Some of the light gets absorbed by the apple's skin, but some of it bounces off. Specifically, the apple's skin is really good at reflecting the parts of light that our brains see as red. So, red light scatters off the apple in all directions. Now here come your eyes. Your eye has a special part in the front called the lens. The lens grabs all those scattered red light rays coming from the apple and focuses them onto the back of your eyeball. Your brain then puts all this information together and creates the image you perceive, an apple. So, how do you bend light around an object? You can't just ask it nicely. You need a special kind of material, something that doesn't exist in nature. Scientists have a name for this stuff, metamaterials. The prefix meta means beyond, so these are literally beyond materials. They are artificial structures, engineered in a lab, patterns, shapes smaller than the wavelength of light itself. Think of them like a very, very tiny, Lego-built obstacle course for light waves. By designing the shape and the spacing of these tiny structures, scientists can control how light behaves when it passes through. They can make it bend in ways that are impossible for natural materials. Glass, water. These metamaterials are the key to building a real-life invisibility cloak. Their unique structure gives them what scientists call a negative refractive index. This isn't just theory anymore. Scientists have actually done it. One of the first major breakthroughs happened way back in 2006. A team of researchers from Duke University, led by Professor David R. Smith, built the world's first working, albeit very basic, invisibility cloak. Now it wasn't a flowing cape you could wear, it was a small device made of concentric rings, fiberglass, copper strips. It was a metamaterial designed to work with microwaves, a type of light with a much longer wavelength than the visible light our eyes can see. In their experiment, the scientists placed a small copper cylinder inside this ring-like cloaking device. They then shot a beam of microwaves at it. Normally, the microwaves would hit the copper cylinder and cast a shadow, creating a disturbance that a detector on the other side could easily pick up. But when the cloak was activated, something amazing happened. The metamaterial guided the microwaves around the cylinder. The detector on the other side saw almost no disturbance at all. The shadow was gone. The copper cylinder, at least to the microwave detector, had effectively become invisible. When you talk to the scientists working on this, you really feel their excitement. They know they are on the edge of something incredible. David R. Smith, the Duke University professor who led that first cloaking experiment, once explained the feeling of seeing it work. He said, "For the first time, we've been able to demonstrate that you can take an object of a certain size and make it completely invisible to a particular wavelength." That statement, while technical, captures the thrill of a scientific first. They had turned a fundamental concept of physics into a real working device, opening a door that had been locked for all of human history. But the experts are also realistic about the challenges. Sir John Pendry, a pioneering physicist at Imperial College London whose theoretical work laid the foundation for many of these experiments, has often put the research into perspective. He famously noted, "A practical invisibility cloak is not around the corner, but the future of this science is very exciting." Ulf Leonhardt, another leading scientist in the field, often speaks about the inspiration he draws from nature itself. He has said, "Nature has played with light for millions of years, creating illusions like mirages. We are now learning to play the same game, but with the new rules of metamaterials." So let's go back to where we started, with Sue Storm from the Fantastic Four vanishing into thin air. Is that kind of invisibility possible based on what we know today? The answer is a fascinating yes and no. The science fiction version. where a person can just will themselves to become invisible and move around freely, is still very much fiction. A perfect invisibility cloak made of metamaterials would likely be a rigid, bulky structure. You wouldn't be able to fold it up and put it in your pocket, and if you were inside it, you'd be blind. For you to see out, light would have to get in, which would make you visible. However, the core idea of bending light to hide something is now proven science. What we are seeing today are the very first steps, the Model T Ford era of invisibility technology. But just as the first cars eventually led to the sleek, fast vehicles we have today, these early experiments are paving the way for future breakthroughs. Imagine surgeons using a tool that makes their hands invisible so they can see tissue underneath more clearly. Imagine engineers designing buildings with cloaking foundations that bend seismic waves around them. Imagine pilots with cockpits where the floor appears transparent, giving a complete view of the ground below. The power of invisibility forces us to think about privacy, ethics, and responsibility. Think about it.